All right, folks. So this lesson and the next really 4 or 5 lessons are on what we call special triangles. So these triangles are special for a couple of reasons, and we'll get into that here in a second. What I want to do first is give you a sense of where we are going with all of this. So this class, pre-calculus, is all about functions. And what we are building towards is a function like this. So all these trig ratios that we've been studying, making them part of our function and seeing what happens to this function as we change x. Okay, you can actually type this into your calculator right now and graph it if you want. What you'll get is a nice kind of periodic wave. So this is like people who study like sound and music like use these functions. Electrical engineers use these types of functions. So these have a bunch of applications that like hopefully eventually we're working towards. What you'll notice if you plug in like whatever random number into x for this is you get a bunch of really ugly decimals. Okay? So the reason we are studying these special triangles is because these produce the numbers that when we plug them into this function, they work out nicely. Okay, so these special triangles and the values we get for sine, cosine, tangent in these special triangles are useful because like eventually we want to have them memorized so we can evaluate stuff like this. It's sort of like what we're building is like, you remember you had your times tables, so you had like, I don't know, 1, 2, 3, 4, like a little grid. And like you'd use this before you learn how to multiply, and you know like 3 times 4 would be 12 because you look it up in the table. We're sort of building that, but for these trig functions. Okay, so that's what we're going towards. Oops. So our first special triangle, there's 2 special triangles we're going to learn about. The first one in this lesson looks like this. It is a right triangle. And a little nicer, it is what we call an isosceles right triangle, meaning its 2 sides, its 2 legs are the same length. And we're going to say it's got length 1 on each of these 2 sides. Okay, so this is our first triangle, special triangle rather. And let's see, based on our knowledge of triangles, we know a couple other things about this. So it makes sense, right, that if these 2 sides are the same, our 2 angles have to be the same as well. If they're the same, and we know that this plus 90 has to add up to 180 degrees. That means these are 45-degree angles. And then we also know 1 squared plus 1 squared equals our hypotenuse squared, right? That's 1 plus 1. Okay. So our first special right triangle is a 45, 45, 90 triangle, or sometimes it's called a 1, 1, 2 triangle. These mean the same thing, and you can see one is naming it by the angles, one by the sides. Okay, so make sure all of this, so you don't need to necessarily worry about this if you haven't copied it down already, but all of this should for sure be in your notes because you're going to want to use this as a reference. Pause, get that down, and then we'll take a look at some problems here. Okay, so in this lesson we are focused on the sides here. So finding a missing side. And this one's about as easy as they come. So find the length of side x in simplest radical form with the rational denominator. So we know how to do all that other stuff, right? And then, not a trick question here. Remember, these are the same length, the 2 legs. So this is 6. Okay. So I'm going to show you 2 ways to tackle these. The first is just using this model. Is just have this triangle drawn and say each of our sides is x, right? So if this side is x equals 7, other side has to be 7 as well. Okay. Now notice, so first of all we're done with this, but notice like what if I had asked you what the hypotenuse was? Notice that like our original triangle in our example was length 1. This triangle is 6 times bigger than that, right? So really we've taken our original triangle, we've multiplied by 6. So what we could do here is just multiply root 2 by 6 for hypotenuse, and we're done. Okay. So that's like one of the nice things about this, is they always exist in this pattern, right? So the pattern would be x, side lengths x, give a hypotenuse of x times square root 2. Okay. So this is like my preferred way of doing it, is thinking of it as sort of an equation that you solve. Like if this is 3, this would be 3 square root 2. If this is 1,000,000, this would be 1,000,000 square root 2, and so on. Okay. The way that Delta Math shows you, they use similar triangles, and they set up a proportion, which some of you really like, some of you not so much. But they said like, well, x over 6 has to equal, and this one's kind of silly, right? 1 over 1. So they put corresponding sides together, and then they cross multiply it and solve. And notice you get the same results, so you can do whichever you prefer. Like I said, this model, the x root 2 model is my preference. Let's look at a couple slightly harder ones. So notice this one here, we're given now the hypotenuse instead of one of the legs. So this would be easy if I had this bottom one, because what x would be the same as that, right? Now it's a little bit harder. Well, if I use my model, which was this, x square root 2, what I can do is I can make an equation. I can say square root 8 equals x square root 2, and then I can solve for x, right? So what I would do here is I would divide both sides by square root 2. And then you need to know what to do with this, right? Well, when both parts are underneath the square root, you can just combine them. So this ends up being square root 4, because I did 8 divided by 2. Oops. And then square root 4 is just plain old 2. Okay. And then, of course, this other side would be 2 as well. So what I've done is I've set up an equation using these corresponding sides. So I said root 8 equal to x times the square root of 2. And then I just solved. Okay, so that's not so bad. We'll do one more for good measure. Okay, here, same thing. I'm going to draw my model. Notice I'm given the hypotenuse again. So I'm going to set those equal to each other. And then I'm going to divide both sides by square root of 2. I get 6 over the square root 2. And now, by this point in your math career, alarm bells should be ringing. I don't like that square root on the bottom, so I'm going to rationalize. And then I can simplify that even a little bit more. 6 divided by 2 is 3 square root 2. Okay, so that tells me my short side is 3 square root 2. And the other side, of course, would be the same. This is new to you guys, but this is not that hard. So make sure you just dig in. Don't give up if you get any wrong, and come back to your notes or the video if you get stuck.